Maps by Paul Blankenship, November 2015. Alabama Geography Standard 1. Describe the world in spatial terms using maps and other geographic representations, tools, and technologies. Explain the use of map essentials, including type, projections, scale, legend, distance, direction, grid, and symbols. Examples: type, reference, thematic, planimetric, topographic, globe and map projections, aerial photographs, satellite images, distance, fractional, graphic, and verbal scales, directional lines of latitude and longitude, cardinal and intermediate directions. Identifying geospatial technologies to acquire, process, and report information from a spatial perspective. For example, Google Earth, Global Positioning System, GPS, Geographic Information System, GIS, satellite, remote sensing, and aerial photography. Utilizing maps to explain relationships and environment among people and places, including trade patterns, governmental alliances, and immigration patterns. Map skills are used in one's personal and professional life. Maps and GPS units help one find one's way. Many professions use maps daily. Examples include geologists, truckers, and the military. Different types of maps serve different purposes, but all maps are liars. Maps cannot accurately represent a three-dimensional sphere without compromises. To flatten out the globe requires us to compromise on the shape or the size of the land masses on the Earth. The larger the map, the greater the compromise is required. Map types. Physical maps show the natural landscape. Elevation is color-coded. We can see on the right a map of Madagascar. The lower parts of the country are green. The more elevated parts are orange. The scale is in meters. On the ocean, the deeper the ocean, the darker the blue. The map is from Wikimedia Commons. Political maps show the boundaries between areas controlled by different governments. Here we see South America, and you're looking at a map of the states of Brazil. So the colorful part of the map are the different states of Brazil. The countries around Brazil are in gray. Economic maps show the economic activities of an area. The map to the right shows exports from Russia in 2006. And you can see the key on the bottom. Russian exports in 2006, shown as a percentage of the top market. And the green would be the Netherlands. The red would be a smaller percentage, yellow a larger percentage, and the largest is in green. Resource maps show the natural resources of an area. The map to the right is a solar resource map of India, depicting the availability of solar energy. So if you were building a solar plant in India, the areas that are more toward red and orange would be your better areas. The blue and green areas up in the mountains would not be as useful. There's less sun during the year because of the weather in those areas. Climate maps show the long-term atmospheric conditions of an area. We can see the climate map of Australia on the right, and if we click through, we can view the key. The orange areas are desert. The yellow are grasslands. Light green is subtropical. Blue is temperate. Tropical is a darker green. And the red-tipped area is equatorial. So this will be the hottest part of the country in the north, because Australia's in the southern hemisphere, the hotter areas are toward the north. The colder areas are in the south. They're near the South Pole. Contour maps show the natural features but illustrate elevation with contour lines rather than colors. They are one type of topographic map. It's cheaper to print in black and white than in color, so contour maps are useful to save money and make printing simpler. Today, color printing isn't as difficult as it used to be. We can see the example here from Wikimedia Commons, and you can see how the lines here and the areas have different elevations listed. So if you're looking at these hills from the side, it would look like this if you're looking down in terms of the elevation on a contour map. Road maps show roads and sometimes other information useful to drivers. And here we have a road map of Alabama. Thematic maps deal with particular themes such as sports. The map to the right shows the locations of the now defunct NFL Europa teams. At one point, the NFL had teams in Europe, but this is where the teams were located. You can see Spain had one. There were a few in Germany, a couple of in Britain. Map projections. A map projection is a method for depicting the curved surface of the Earth in a flat map. Types of projections include the Mercator projection and the conic projection. There are other types. The Mercator projection was developed by cartographer or mapmaker Gerardus Mercator in 1569. The straight line grids were useful to navigators in the age of sail. So if your objective is to sail east to west or west to east, those straight lines are very useful, very helpful, even though they cause the extreme north and south of the map to be very distorted. If you look at the Mercator projection up at the top, Greenland looks enormous. It looks larger than the United States. But check out the globes in the classroom or at home. Look at a globe or look at Google Earth and then look at the real size of Greenland compared to what you see on the Mercator projection. It's quite different. And at the bottom, the South Pole is just this huge stretched out landmass. At the very bottom, this would be a single point on the Earth, or it would be very near to a single point, depending how far south they've drawn. Looks entirely different from the real world. But again, if you're a sailor, you're sailing around this part of the world, very useful. It's a cylindrical projection, distorting the spherical globe into a cylinder. Navigators in the age of sail found the projection useful because it helped them set straight line courses at sea. It helped them follow the winds and currents from the old world to the new world, across the Atlantic in particular. The Robinson projection, developed in the 1960s by Arthur Robinson, a geography professor. Less distorted than the Mercator projection, the lines of longitude curve in at the poles. With the curvature of the Robinson projection makes the north less distorted. It's still somewhat distorted, but less distorted than the Mercator projection. So we look at Greenland. You see the size of Greenland here. It looks like maybe half the United States. Check that against a globe. You'll see it's still exaggerated, but it is less exaggerated than the Mercator projection. The conic projection. Rather than a cylinder, this projection is based on the shape of a cone above a pole. So it looks like this, like an ice cream cone turned upside down over the Earth, a waffle cone. The cone touches on a certain line of latitude. The resulting map is shaped like a fan. Shape is correct, but the size is distorted. Map scale is the ratio of distance on the map to distance on the ground or at sea. For example, a 1 to 100,000 map scale will show that 1 centimeter on the map represents 1 kilometer on the ground. To find that in imperial units, 1 inch would represent 100,000 inches because the ratio is the same, or 1.5782828 miles. It does not matter whether the map expresses distance in metric or imperial, the ratio would be the same. It's a 1 to 100,000 map, whether it's metric, imperial, or something else. Map legends. A map legend or key List explains the symbols used on a map and provides other information about the map. Here we have an example of a map key. And you can see they have different types of lines for foreign territory, other international boundaries, foreign territory claimed by India. So the legend explains what the symbols and the lines on the map mean. Map distance. Distance is the space between two things, obviously. The map scale relates the distance on a map to the distance on the ground. Map direction. The cardinal directions are north, east, south, and west. The ordinal or intercardinal directions are northeast, southeast, southwest, and northwest. The secondary intercardinal directions are north-northeast or east-northeast, and so forth. That would be the smallest of the spikes going out of the compass rose on the right. And the compass rose shows direction on the map. We tend to assume that north is up. That's true on most maps today, though not all. In the Middle Ages, east was up because in Europe, Jerusalem was to the east and Jerusalem is holy. So we'll put Jerusalem at the top of the map for theological reasons. What is north? A pole is the point at which the axis of the earth meets the surface. So the North Pole will be the point that the axis of the earth meets the surface in the northern hemisphere. The magnetic North Pole, however, is the point in the northern hemisphere where the lines of magnetic flux enter the earth. So the magnetic North Pole moves around because of phenomena under the Earth's crust, and that changes. It's not exact. It's sort of an area more than a point. But the other pole, the true North Pole, that does change, but over a very, very long period of time. Over thousands of years, you might notice a difference. Map grids use the Cartesian coordinate system developed by French polymath, that means someone who's good at a lot of things, René Descartes, to describe locations on a map. Map grids use lines of longitude and latitude to help map users find locations. The United States National Grid is used by the Department of Homeland Security and other organizations to describe locations in the United States and abroad. And we have a link here. And this is the website that describes the United States National Grid. It gives the grid zone designations, or GZD. And you can see South Alabama will be in 16R. Right here, north of Alabama will be in 16S. We have the 16s running across here. And then the R's are here, and the S's and the T's. Why Homeland Security? If there's a disaster, man-made or natural, they need a way of describing exactly where it's happened so aid can be rushed there. Map symbols. Maps often use common symbols to indicate various features. For example, the United States Geological Survey, the USGS, uses a common set of symbols for all topographic maps. And we have a link here. And here we have a document with the topographic map symbols. On any of these links, if you go on my website, cmsblankenship.com, you'll find the PDF version of this presentation for Geography 1. And all the links are present in the PDF file for the presentation, so you can click through and look at these. Geospatial Tech, Google Earth. Google Earth is an app that provides the user with a customizable virtual globe. And there's a link here for downloading that. It can be done as a plugin in a browser or a separate app. Google also produces a related product, Google Maps, the flatter, less 3D version. Let's take a look at Google Earth. And here we have the Google Earth plugin and a button to download Google Earth. If you want to install that, you download the Google Earth plugin. That puts the maps in your browser. I'm on Safari on a Mac at the moment, and it'll take a little while to download. You can also go up to the top to download Google Earth, click there, and then you would click agree and download, agreeing to these terms if you do, or if your parents do, if you're under 18, and Google Earth will download. Geospatial Tech, Global Positioning System, or GPS. The GPS uses a series of geosynchronous satellites to to help a receiver determine its exact position. A geosynchronous satellite stays about the same point on the surface of the Earth. It doesn't move relative to the Earth, but it moves with the Earth. So as the Earth rotates on its axis, the geosynchronous satellite moves with that rotation. So the satellite's always moving, but it's moving at the same speed as the point on the Earth below it. So relative to the Earth, it's always in the same spot. So if you set up, say, a dish or a direct TV dish for satellite TV, you can point it at that satellite from your house, and as long as it isn't moved, it can get the signal from the satellite because the satellite stays in the same spot relative to the Earth. But you have to keep in mind that the Earth is always moving and the satellite's always moving, but they're just not moving relative to each other because the speed of the satellite is synced with the speed of the Earth. The Global Positioning System, or GPS, was created by the United States government, and here's the official site, gps.gov. And here you see a complaint page if you have issues with GPS, if your neighborhood hasn't been added to map makers, or if they're routing trucks through your neighborhood, you can complain to the device or map makers. They're saying, hey, it's not our fault, it's the map makers who aren't using our technology correctly. More geospatial tech, the Geographic Information System, or GIS. We have an illustration here on the side from the Government Accounting Office, or GAO. A GIS system deals with data about the surface of the Earth. The layers of data allow users to compare phenomena such as air pollution and the presence of roads on the map. So here we have an illustration from the government. You have street data, where the streets are. That's one layer of data. There's another layer for buildings, another for vegetation. You put them all together and you get a picture of the streets, buildings, and vegetation in an area. But if you want to examine just one aspect of that area, say just the roads, you can tell it not to show the vegetation, not to show the buildings, and you would just get the roads. Geospatial tech, satellite remote sensing. Remote sensing from satellites or aircraft use energy reflected from the Earth's surface to gather data for mapping. Some systems passively collect energy, while other systems, such as radar or laser, project energy and then collect the reflection. And then we have aerial photography. Aerial photography means taking photos of the Earth from the air. Airplanes, telescoping masts, balloons, blimps, dirigibles, helicopters, and drones are used in aerial photography. Mapping trade routes. Mapping trade routes helps one understand the geographic aspects of the economic relationships. Here we have an example of a trade route map in Google Maps. Okay, so here we have a trade routes map showing many historical trade routes. Now it's so crowded here, you really can't tell one from the other. Let's zoom in. Mapping governmental alliances. Mapping governmental alliances can help one understand the nature of the alliances. The location of the allies often indicates the nation or nations they're allied against. They'll tend to, when possible, surround or partially surround the nation or nations of concern. The North Atlantic Treaty Organization, or NATO, provides an interactive map outline and a game based on that map. And here you see the NATO on duty map. It shows NATO missions deployment against a GIS. There are different layers to it. I can check a box. Now I see a new layer, troop contributing partners. So these are the countries that contribute troops to NATO missions. I can see their command and control locations, where their headquarters are for different missions. I can see who's sharing knowledge with NATO. The Partnership for Peace partners. So in the past, NATO was mainly there out of concern with Russia, but for some things, they cooperate with Russia now, like the Partnership for Peace. Mapping immigration patterns. Mapping immigration patterns shows how people move from one area to another. Maps of immigration patterns may provide clues about why people are moving and what resources may be needed to help them. MigrationPolicy.org has a collection of maps of current immigration patterns. And we'll take a look at immigrant and immigrant. IM means coming into a country. Immigrant is leaving a country. Immigrant and immigrant populations by country of origin and destination. So we click there. We get interactive map, another GIS. Migrants in the United States from China, 2,247,000. And here's where American immigrants are. So people from the United States, there are 24,000 Americans in Brazil, 3,000 in Uruguay, 317,000 in Canada. So Americans move overseas, 223,000 in Britain. So the largest number, and it kind of makes sense based on the geography, Mexico, 849,000 Americans live in Mexico. So the orange dots show countries where people move to the United States, 12,951,000 migrants in the United States from Mexico, 2,061,000 from India, 71,000 from Australia, and then Japan, 346,000. So it's kind of a fun map to play with and look and see where people move from one country to another around the world. In conclusion, map skills are important for everyone. Playing video games that use maps, such as Minecraft, provides practice in map skills. So when you're playing video games and your parents say you should be studying, you can always say, well, Mom and Dad, I'm improving my map skills. I'll back you up on that. Maybe. We've examined several aspects of maps and geospatial technology. And here are my sources. There's quite a few. Again, you can look at these, the PDF version on my website, cmsblankenship.com, if you need to check any of these or look up any of this information, maybe for projects you're working on. And this work is licensed under a Creative Commons Attribution Non-Commercial 4.0 International license, as I have used many Creative Commons elements and maps from various sources, such as Wikimedia Commons and the Government of Australia. In turn, I release my information, as I'm required to do, under a Creative Commons license so that others can take my work and remix or reshare it within the boundaries provided by the license. And remember, if you do any school projects that you release to the public, you need to put the Creative Commons license in that as well if you pull from sources like Wikimedia Commons.